Today, we are opening up the case file on what is, without a doubt, one of the biggest detective stories in the history of science. We're talking about the origin of the incredible, mind-boggling diversity of life on Earth. And the craziest part? The clues, it turns out, have been hiding in plain sight for millions of years. You know, for as long as humans have been around, we've looked at the world and wondered, where did all of this come from? How on earth do you explain the millions and millions of different life forms, from the tiniest insect to the biggest whale? For a long, long time, the answer seemed pretty straightforward. Divine creation. Life was designed, full stop. And this idea was celebrated in these magnificent places, like London's Natural History Museum, which was literally built to be a cathedral to creation, a place where you could go and just marvel at the work of a grand designer. But what if that wasn't the whole story? What if the answer wasn't a single event, but a long, sprawling investigation? A cosmic cold case, with clues buried deep in rock, hidden inside the bodies of living things, and even happening right under our noses. And that's where our lead investigator comes in, Charles Darwin. Now, he didn't solve this case overnight. Oh no. In fact, he spent decades patiently gathering evidence, building his case piece by painstaking piece. After figuring out his theory, Darwin just sat on it for over 20 years. Can you imagine that? He knew he was holding this scientific bombshell, an idea that would completely rewrite our understanding of, well, everything. And he was absolutely terrified to light the fuse. So why wait? Well, the risks were just enormous. He was facing a potential firestorm on 3 fronts. First, a huge challenge to the church. Second, massive professional pushback from the scientific establishment. And maybe most importantly, on a deeply personal level, he was afraid of hurting his own deeply religious wife, Emma. And let's talk about the scientific establishment for a second. Take a look at the man on the left here, Sir Richard Owen. This guy was a superstar anatomist. And ironically, he was the founder of that very cathedral to creation, the Natural History Museum. He was brilliant, powerful, and he represented the very institution Darwin was about to challenge. So with stakes this high, Darwin knew his case couldn't just be good, it had to be bulletproof. So he organized his evidence into several key files. Let's open the first one, the clues from history, baked right into the rock of the Earth itself. Okay, so Darwin made a really clear prediction. He said, look, if all of life was created at once, you'd expect to find fossils of, say, rabbits and bacteria and dinosaurs all mixed up in the same rock layers. But if life evolved over time, you should see a clear pattern. The simplest life forms in the oldest, deepest rocks, with more complex things appearing only in younger, more recent layers. And wouldn't you know it? The fossil record confirmed his prediction perfectly. It's not random at all. It's a beautifully ordered story, told in stone, a clear progression from simple to complex over vast stretches of time. This was a massive clue. All right, one clue down. Now let's move on to the next evidence file. This time, Darwin looked at the design of living creatures and the really weird patterns he started to see. He noticed something absolutely fascinating. So take a look at the arm of a human, the front leg of a lizard, the wing of a bat, and the flipper of a dolphin. They're all used for completely different things, right? Grasping, walking, flying, swimming. But they are all built from the exact same set of bones. It's the same shared blueprint, just tweaked for different jobs. Which leads to the critical question, why the repetition? I mean, if you were an engineer designing a wing from scratch and then a flipper from scratch, you'd never use the same parts. It doesn't make sense. The most logical explanation, Darwin argued, is that they all inherited this basic structure from a common ancestor. The clues get even weirder and deeper when you look at how creatures develop before they're even born. In their earliest stages, the embryos of a fish, a tortoise, a chicken, and a human, well, they're incredibly hard to tell apart. They all start out looking remarkably similar. And here's where it gets really wild. For a short time during our development, human embryos have gill slits. Yeah, gills. That makes absolutely zero sense for a mammal that lives on land, unless, of course, our very, very distant ancestors were fish. It's like a developmental echo of our ancient past. And sometimes those echoes stick around even after we're born. We call them vestigial structures, basically leftover parts that an organism has but doesn't use anymore. A perfect example is this blind cave fish. It lives in total darkness, so its eyes are completely useless, but it still has them. Why? because its ancestors lived in the light and needed them. They're just anatomical leftovers from its evolutionary history. Okay, now for the final file, the one Darwin considered his smoking gun. He obviously couldn't watch evolution happen over millions of years, but he realized he could watch a powerful, fast-forwarded version of it in action. He turned his attention to domestication. For thousands of years, farmers and breeders had been shaping animals and plants to fit their needs. This was selection, all right, not by nature, but by human choice. He called it artificial selection. Darwin got obsessed, and I mean obsessed, with pigeons. He saw how these pigeon fanciers, just by picking and choosing which birds to breed, could create these incredible, wildly different breeds in just a handful of generations. And they all came from one single common ancestor, the humble rock dove. The logic was so simple, yet so powerful. It really boils down to 3 steps. Step 1, variation. In any group of animals, there are slight differences. Step 2, inheritance. Those little differences get passed down to the kids. And step 3, selection. A selector, in this case a human, gets to choose which individuals get to pass on their traits. Variation, inheritance, selection. That's it. That's the engine of change. And this is where Darwin's argument becomes so compelling. Just look at what we've done with dogs. From a single wolf ancestor, humans created this unbelievable diversity in just a few thousand years. So Darwin's question to the world was simple. If human breeders can do all of this in a geological blink of an eye, what could the relentless pressure of nature itself do over millions and millions of years? Now, Darwin was a great detective, but he was also an honest one, and he knew his case wasn't perfect. He was very aware that there were some missing pieces. He had no idea how traits were passed down. Genetics wasn't a thing yet. The fossil record in his day was pretty patchy, and a lot of his arguments were based on logic, not the kind of hard data you'd see in physics. But this is the amazing part. In the century and a half since Darwin published his book, science has found those missing pieces. We discovered DNA, the actual mechanism of inheritance he was looking for. We've unearthed countless new fossils that perfectly fill in the gaps. Every new discovery has only made his fundamental case stronger than he could have ever imagined. And that leaves us with one last really fascinating thought. Darwin's detective story isn't just about solving a mystery from the deep past. The process he uncovered is still going on, all around us, all the time. So the question isn't just, where did we come from anymore? It's, where can we see evolution happening right now?